welcome to another teardown video. This is another Philips, a PM5100 LF generator, low frequency, so it's a sine wave generator. I've been looking a little bit on the internet. Especially Radio Museum is just the way to go. You can find schematics and information about this product. And they say it's from the start of the 60s. And it's tube based. And there is a diode rectifier in it. It's probably germanium or something. But it's not a tube rectifier, so I look forward to see if it works. Everything here feels quite alright. This one is a little bit stiff. So this is the output voltage range and variable. And this is kind of all it can do. It's just a sine wave. And in 4 different ranges like that. So, and before we, it's actually quite heavy. It looks like it has been in use quite a lot. So it's a PM5100-06, 40 watts. This is also good to check. And that will be the fuse, and it is for 220. That feels all right. And it's nothing is loose or anything. So let's plug it in and see if it uses about 40 watts. So I think we're ready to power it up. I actually was looking for where the heck is the on-off switch, and I realized how stupid I am, because I'm looking at this angle, right? Duh. Okay, the light is just bad here. It says off down there. So it's the output voltage you need to dial, and then it goes on, and then you crank up the level. So that means if you need to remember or make it go back to a very accurate level or something, you need to measure it every time, because of course you screw this up every time you turn it on and off. So maybe you need another external on-off switch or something. That's just a little bit. Yeah, okay. I guess this is also kind of the super cheapest. I haven't seen anything smaller or more simple from Philips. Please correct me if you found something that is even more simple. So let's plug in the scope here. And this is an off. Okay, we crank on 224 and nothing. And let's see. Ooh, that's not what I expected. 0. Why? Oh no, the fuse is broken. Let me try again. Is it just a... No. So the fuse is broken. Okay, I need to check it out. Oh no, fuse is okay. So what is causing this not to work? This will be the next place to look. I think I found the problem. Yep. Do I really need to include a little clip about how we do this? I actually didn't want to make this video a lot longer or about a lot other stuff that is not relevant, but see guys, this is why it is not working. So when you screw down on wires that is just done like this, they can bend quite easily, and this will cause all sorts of problems. See? There's almost no material left when you screw down on the wires like this, okay? So what we want to do is we want to cut away all this old crap, and let's make this right. So this is the material you want, and so about here we cut the wire or the isolation away. About 11-12 millimeters. Look at those wires. They're not really super clean anymore. I'm not too happy about reusing this kind of this color is really not so good. So but this is a super low power equipment, so it for this it will work. But normally my advice is, if you see dark wire, black wire like this that is not clean, discard the entire wire, or at least cut more and more away until you see a perfectly clean copper colored wires. So when you twist them first as hard as I did and then bend them backwards, there will now be enough material for this to work. All right. And see again, if you can put this in like this, now you can imagine the material the screw will hit will be super good. When you put this all the way up here, oops, this is what happens when you try to do it real fast and make a video at the same time and have a camera in the front and I don't know what else, so it's not gonna look so pretty. See, I want it to look nice and beautiful. And then the rest is easy, okay? So let's see if this good old thing is gonna work now, okay? So we're ready to try and see what happens. Okay, 60 watts, 47, 40, 38. Okay, so 35, 33, so no. Okay, no. Ooh, we're having difficulties. Oh, we got DC on the output. How lovely. Ah, okay, so this pot is a little bit noisy. See the crackety. Ooh. Okay, and this one is working good. But we got a lot of DC coming out of this. I am in DC. Good. Look at that. That is funny. Ooh, I can hear. I don't know if you're able to hear this. Well, let's put the camera closer. Ah, that is cute, isn't it? So this is 2.8 kilohertz. Okay, so all the way down here is 1.3 kilohertz. Yeah, okay. This should be 1.5. Yeah, okay, it is 1.5 kilohertz. Look at that. So it says 15 here times 100. Yeah. Okay, that is actually really good. So let's go all the way. So that was 1.5 kilohertz. in the middle here is like 4. Yeah. Wow, that's accurate. Look at that. I love it when this good old tech is accurate. So if this is 4, let's go all the way to 15. Right? So see, should be 15. And let's see what it says. That's pretty close to 15, isn't it? I'm actually quite happy about that. Let's go down and see if we can make... Ooh, of course I should do like this, right? So that's 500, okay. 15. No, that is of course 150 hertz. No, duh. 150, right? Okay, it should also go even... Wow, even that works. So that is 15 hertz. Super slow response. Oh, that's a classic thing when digital scopes, right? It's a little bit behind when it comes to stuff like this. But all right. Oh, that works. All we need to do is now... Ooh, look at that. Oh, we got the classical connectors. We need to just exercise them a little bit. So that is 25 kilohertz. Let's go all the way. And it's 150. Yes, it is, definitely. So that is 150. Yay! Wow. Oh, and the DC on the output is also more or less gone now, isn't it? So that means there was just a capacitor, or it has also something to do with this. The scope here is really high impedance, right? So I am not loading the capacitor in the output. So that means you will see DC voltage out quite a long time. So that is why we see this. And the pot meter here is just getting better and better. We just need to exercise this a little bit. But yeah, it seems to be working real good. All I need to do now is measure the distortion. Maybe we should do that. Let's just do a screenshot the super old-fashioned way, shall we? So this is a spectrum including THD, 0.1%. So it's not that bad. And this is the 1 kilohertz. This is the wanted frequency. And this is a mains supply 50 hertz and 100 hertz and 150 hertz. And so all this is simply just capacitors in the power supply that's not working good enough. What we see here is 2 kilohertz and 3 kilohertz on that. That's actually my sound card. So this is what I see on all signal generators, even the best you can get. So that's a fault in my sound card. But anyway, all this this is real, what we see here, and that is related to the power supply in this signal generator. And even the bulb works. Is that a neon or something? No, it's a real bulb. Wow, look at that beautiful shine. But I think it's time to tear down what is inside. Ooh, it's nice and warm. And they said about 40 watts on the back. That is not true. It's all the way down to 28. Okay, so that was too easy. The rear plate was just with 4 screws in the corner, so that was easy, but it's not coming out that easy. Oh, you need to pull this, and then you twist it. Okay. A few different versions exist, with or without this voltage selector, I guess, or maybe you don't have it as visible from the outside of this. So here's a hole where you can see the setting, and to be able to change it, you need to take off the rear plate. But I've seen other versions without this visible. We got a few trimmers. So how do I get in this? Normally the feet comes I need... Really? Damn, some more screws. Okay, so you need to take off all the feet and the little holder. Oh, we got some tubes. Ooh, that is a sexy little EF95. Oh, I love them super cute ones. EF86. The other one is probably... What is that? And the bulb. Oh, that is nice. So it's not sitting straight. How cool is that? Is that wet? No, it's not. I need to be a little bit more careful about how I touch stuff, because it's not long ago it was powered up. So I don't recommend you do exactly what I do. But be a little bit more careful around the areas where you see capacitors and stuff, right? It's just because I've been doing this for quite a while, so I get, you know, a little bit not so safe anymore, I guess. And there's a little trimmer. This one was actually accessible from the outside as well. And here is, ooh, that is a big boy. A big capacitor. This is dirty here. Look at that. So when this is running really, really nice and warm, we are gonna smell something here, right? So what I'm gonna do now, I'm gonna go and get this cleaned. So that was better. After a little bit of cleaning, we can now see the beautiful internal parts. So nice printed circuit board, double trio there. And so, oh, this one is pretty cool. So here is the output capacitor, DC block for the output. You can actually see this is the big capacitor. It goes up to those solder points. That goes to the output attenuator. That one, that will be the output, right? So look at the metal, the shielding around it. See, there's a wire going down to the PCB, and that wire goes around here. There's a black wire that goes to the capacitor chassis here. So this is how they connects the shield of that capacitor. That's pretty cool. The 182cc, yeah, so it was this a double trio. It's a this computer grade or computer quality or whatever they call it. At least it's a pretty good quality component, so that is good. In we go again. Got some really beautiful power resistors, and they're perfectly sized because they're not brown in any way. So that means they did a good job derating components, so nothing runs too hot. Let's take off the back plate and see if we can see some more. So that is the rear plate removed, and see, that was the capacitor I was talking about that was hanging in the back. And see, if I paid a little bit more attention to detail, I would have seen we got some connectors right here. So I could have just pulled out this and left this up here as well. So that was a little bit dumb. And what have we got here? I believe that will be the two bulbs. Where is that? Inductors, but I think that will be the bulbs, right? So we're looking for two bulbs that is in series with the oscillator system, and they're used to stabilize the output with drift and frequency and everything. So I believe they're in there. Maybe they're in a socket or something. It could be cool if we could see them a little bit better, because I can't find anything else. It gotta be that, right? See, that was the rectifier I was talking about. So, oh, I think this is selenium, right? This is definitely a selenium rectifier. So it's made of thin layers of selenium plates in 4 rooms inside this piece of a Bakelite, I guess. Yeah, I took a few of these apart when I was a kid. It was a lot of fun and a lot of mess. So that tube, when I pulled it out, it was hammering into the metal here. There's just not enough room. I needed a few more millimeters of space here to be able to pull out this tube correctly. Ooh, see, that is the dirty side. I want this to be clean so there's no ugly smells when this is running in the future. But I wasn't happy about this tube looking like that. So why is it not sitting nice and straight like that is how it should look like. I was trying to fix this problem with the mains. Wire is just too short. There's no way you can handle. The back plate is just completely in the way, and this wire is just like you can hang your clothes on it. And so this I try to dismount this PCB, but again, all wires here, they're so short. There's no way I can move this. I wanted to access the brown wire that goes to the main switch, because if I can desolder that, then I can change it for one that is a little bit longer, and that will help a lot on all this. The blue one goes up here to the fuse, so that's easy. Earth wire is easy to access right here, but so that is a little bit of a problem. Got all these wires for the mains stuff here. Let me see if I can fix that. So now it is nice and clean. I fixed this wire, so now you can have the back plate here and you can easily access everything and put in the tubes and everything. Sometimes when you take out old tubes and you clean them up because you want to fix this smell that old tube gear emits when it's in use, sometimes the text goes away from the tubes, and that is just a known problem. But then please always use a permanent marker, add the number on the tube again, and write on the back side or top side or any side where it is easy to access and to read in the future. Because when you do this, you will help future technicians to fix this. You gotta see this little funny detail here. So this hole here is of course made so this can be taken out, right? But look, they didn't take account for the bent radius when they designed this, so look what happens. It's a little bit too long, so it cannot get out. And also, because of this bend, and this capacitor is mounted here instead of a little bit up here, for example, then it could have been taken out. So there's no way this can come out without you take out the back plate anyway. Duh. That is just so obvious. See this little detail here? See the distance? It is exactly the bent radius problem. That is a classic bent metal kind of thing that takes us all. Yeah.